So solution. Oh, I spilled my soda. Sad to have water. It blew up before class. My soda. I dropped it. For those of you who don't work here. Explode. Huh?
What type of soda?
It was just a Diet Coke. Yeah, I just had one. It's fine. I don't need more caffeine anyway. No, 5 points. No kidding. No, I'm kidding.
Do you want me to gum?
No, I have gum. What kind of gum do you have? Yeah, I'll take one. Yeah, sure. Thanks. Yeah. Camera. So, thanks. Oh, I got 2 pieces. That's fine. Okay, so m squared plus 5 was really good gum. So you get that. It's going to come out in the mic. No one watches this anyways. Everyone see why it's a 5? Oh, you do? Oh, good. Okay. Then you subtract a 5, subtract a 5. I don't watch them. I don't watch this. I can't stand watching myself. I have to walk away and say, I don't care. I don't care. Take the square root.
So plus or minus imaginary.
There you go. That's how pros do it, Rafael. Very good. Plus or minus I squared of 5. Huh? Right, you have no alpha, but you have a beta. So you could write it like this. 0 plus or minus I squared of 5. Well, that's some really good gum, Anna. Alpha is 0, and beta is square root of 5. So the formula has C1 e to the alpha x cosine beta x, C2 e to the alpha x sine beta x. Wow, when I breathe in through my mouth, I can like feel the gum. It's dentine ice.
It's very intense.
Yes, it is. Okay, so this is really good gum. Cosine square root of 5 x. Wow, that's ugly, right? That's your beta. Beta is the square root of 5 plus C2 sine square root of 5 times x.
The alpha is like a little.
And that's a C.
Right? If we have
Yeah, the alpha, the formula would be this. Oh, worth it. Good question.
So that's not YP yet?
No, that's YC. I accidentally called it Y. I don't know if you saw that, and I put the C there.
Okay, yeah.
If you're taking the test and you call it Y, on this problem, I'll let it go. Yeah, on this one though, huh?
What does YC mean? What does YP mean?
So basically the solution is YC plus YP.
Yeah, so what does C and P stand for?
C stands for complementary. I don't know why they call it that. I guess it complements the other solution. Basically, YC, if you pretend this is equal to 0, which is what we did, it's the solution to that equation. So it's like the homogeneous part of the solution. So the answer is the homogeneous part plus the non-homogeneous part.
Okay, so in the first part, we'll never use the stuff to the right, but for the YP, we use the stuff on the
Yeah. So first part is YC. This is from 4.3 also. Like you'll have like 3 questions on your test where it's 0 here also. Yeah, good. Good question, Udash. Good.
But why
Good.
is it that the complementary function looks like this? Is it always cosine?
It's
I just don't remember.
because it's complex.
with the imaginary.
So because we had to take the imaginary number anytime we get
So there's a form point.
Yes, anytime we're working with complex conjugate roots, which is the specific type of root that you find with your y, you're going to be using your alpha and your cosine and your sine.
Good.
Is there 3 cases? There's when m is like a repeated, there's m with 2 different.
Right. Right, there's 3 cases. So this is the complex case. If you have different answers, like m equals 2, m equals 3, good Nick, you would get c1 e to the 2x plus c2 e to the 3x. And then Nick, if you had a repeated root like 4, it'd be c1 e to the 4x plus c2x e to the 4x. So this is one case, this is another case, and this is the third case.
You
Good.
can have a blended, so like maybe you have multiple cosines, and you have to apply an x or an x squared.
Beautiful.
That right there is not going to be on the test that we didn't memorize that. Right?
What? Oh, these stuff? Oh, yeah, you'll have to. Yeah, you'll know it by heart, though. Like, when you study, you'll be like, oh, yeah. Like, you will. You'll definitely know it. Like, oh, my God, yeah. Yeah, that'll be no one ever forgets it. Well, that's not true. Usually, people who forget that miss everything else also. It's very rare. I'm not saying it's like everything. All right, B. Form of YP. Yeah.
Question about that. There was one of them on the homework when it's like that, but instead of 5 it's 25, and I like split it up. I tried to do it like that, but it didn't work.
Show me during the break. I'll look at it. I'll show you. We'll look at it. Yeah, because I can look at your homework. Maybe it's you entered it wrong. I'll look. The form of YP, it's usually what it is, like when you think you did it right and it's wrong, like you just forgot to enter something or something's like in the wrong place. We only look at the right-hand side, like Udash was saying, right? So we have a quadratic times e. So our initial guess, it's a full quadratic. So
Squared plus bx multiply that by d. Oh, no.
e to the 5x. You don't need the d. You don't need the big D. What happens? Let's put a big D there. Look what happens. Because he said D. So let's say you put a D here, because people always ask about it. If I put a big D here, see the big D? Well, look what happens with the big D. The big D gets distributed to the big A, and you get big A times big D. That's a new constant. So you don't need it. So because the big D gets absorbed.
So you never multiply any constants. If you do that, you know it's wrong.
Mm-hmm. Wait, I think I just agreed and I didn't hear what you said, but.
So you can't multiply. You can't multiply constants. If you do, it's going to be wrong.
Yeah, it's not. Yeah, okay. Yeah. Right. Yes. Yeah.
Yes.
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 I don't think I'd ever have. I think yes.
And you distribute it?
No, just leave it. Just leave it. That's it. That's the answer. Look, there's no repetition. That's it. So we're done. All right. You look here. You look here. Nothing repeats, right?
I knew that.
Okay. Yeah.
Why do you only write the e to the 5x?
Constant is redistributed to the other constants.
Because this is your quadratic. This gives you this, and this just hangs out.
Okay.
So if you put a d here, like Rafael was saying, like 'cause if it was just e to the 5x, your guess would be this, right? But you don't need that because you already have this, so you don't need both. And then you're supposed to look, right? You're supposed to check. You're supposed to look here, and then here, and there's no repetition, right, between these and this, right?
There is repetition. What do we do?
Well, it depends. It depends on the question, right? That's what we were doing last time. We'll review that later.
That's what we did last time.
That's harder. Yeah. Depends on the situation. All right, so that's it for that one. This is the worst part in this problem, I think. I think I can do it here. I'll try. Part C, find YP. Maybe I can't do it here, but I'll try. Solution. I'll probably have to go to the other board. All right, so the first thing we have to do is write down YP. Yes?
So, if the YC is a quadratic, is it still no repetition because it's all being multiplied by e to the 5x?
Right. There's still no repetition because it's all being multiplied by e to the 5x.
Okay.
Right. We'll do one after this where you're going to get funny repetition. I know which one it is. I'll pick one from the homework. It's really tricky. I did it this morning on accident, and I'm like, whoa. It caught me off guard, but we got it right. So I'm going to write it again. YP equals ax squared plus bx plus c e to the 5x. And then, how many times do we have to take the derivative of this? Twice, yeah, because it's the second derivative. There's someone in the homework with a 3 there, too, third derivative. You might say, oh, it's really hard. It's not. It's not. It depends on the question, right? Like in the last example, the third derivative would have been a piece of cake. This one, though, is not fun. So you have a choice. You can distribute or just do it. I say we just do it. It's fine. Product rule. Let's do it. So it's all about. So the derivative of the first is 2ax plus b times the second plus the first, ax squared plus bx plus c. So the derivative of the first times the second plus the first times the derivative of the second. 5e to the 5x. Yeah, it's e to the 5x times the derivative of the inside, so it's 5. Let me pause here. We'll clean it up in the next step.
You didn't put a prime on the YP.
Rafael. Thank you. All right, that's a mistake. Okay, so let's clean it up. Won't happen again. Okay, 5, 5. I'm gonna put that in the front. So YP.
I can go buy your Diet Coke because you didn't put it again.
I did it on purpose. I'm still. Yeah, I was waiting for you. I was waiting for you to say something. Look, you see it? You see that?
Me too.
Me too, double.
I didn't take the derivative again. I'm cleaning it up. That's the point. No. Oh, come on. No. It's got to go both ways. All right, I'm going to leave it like this.
No, I like it this one-sided way.
It's all right. It's all right. 500-point test. No, I'm kidding. The points are meaningless now. 1,050 points. No. Then it backfires. So this is. I'm going to put the 5 in the. The 5 is really bothering me.
It's ugly.
What should we do with it?
Put it in the front, and then put e to the 5x at the end.
Put it in the front.
Yeah.
Let's just do what Anna says. Yeah.
5 parentheses, and then e to the x and x.
Like this.
Yeah, that way we can just take in the next derivative the 5 and add it to the front, and keep our e.
Yeah, take this. This will be one piece, and the 5 hangs out only different. Good, smart Anna. Oh yes, good, pro, good. I was just cleaning it up, so we're here. I don't even have a Diet Coke. Thank you though, Udash. All right, so now we got to do it again. We got to take a derivative again. I think I'm gonna have to come to this board because I don't think I can fit that there. There's 2 product rules.
Yeah, that's fine.
Huh?
One not, but we have 4 like chunks.
4 chunks. Yeah. So why be double prime?
Got it.
I'm looking at Udash now. So it's the derivative of the first times the second. Sorry. What's the derivative of the first piece? 2a. Good. 2a times the second plus the first 2ax. No, I ate a lot of food before class. I brought like.
Up there in front now, or
What?
That's gonna be 5 again.
I don't know. Right, do you want to put the 5 in front of that parentheses right now? That way you don't have to write.
Yeah, you don't have to rewrite it. Just
No. I don't want to make that leap. That's too much for me. So derivative of the first. My marker hasn't moved. Derivative of the first times the second plus the first times the derivative of the second. No, I got to go in order. Like I'm a noob. I got to do it. I got to show the step. Yeah. You can though. You can. I see what you're saying. Let me just double check that. That's really ugly. So the derivative of the first, boom, times the second, boom, plus the first times the root of the second. Then plus. Yeah, and I was saying I had a lot of food before class. I brought like 3 tuna fish sandwiches here, and like 2 giant wraps, and like an apple, and like. This is the first piece. So it's the derivative of the first, and notice the 5.
Yeah, I was wondering what the 5 was doing.
It's just going to hang out there. So Anna's strategy is to put.
Keep adding coefficients.
So the derivative of the first, watch, the 5 hangs out, and you get 2ax plus b. That's the derivative. And you can do that because it's 5 times a function of x. So you have a number times a function of x, the number always hangs out. So you're allowed to do that.
Okay.
Really clever, right? Times the second plus the first. ax squared plus bx plus c times the derivative of the second. Ridiculous. Does this problem seem worse? Yeah, right, Matthew? I think so too. Oh my God, I agree with you. I think this is way worse. It's all the derivatives. Technically, it's not supposed to be worse. It's supposed to be easier. The last one is supposed to be super tricky with its technique. It's like that ancient technique of equating coefficients destroys people. Let's rearrange everything as Nick was saying. Let's put the 5 here, etc. It's ridiculous. So 2a, yes, the last one's 25 plus. Oh!
So you have 10, right?
Yeah, Nick. Yeah, check it out. Look, we have 5 of these and 5 of these. So 5 plus 5 is 10. Yes. Awesome. Good observation. That's pretty cool. I'm going to put tildes above them so you see what's going on. So there you go. Combine those. And then this one is 25. 25. ax squared plus bx plus c e to the 5x. And the 25 at the end. All right, that's not so bad. Not so bad. Any questions so far? Now, what do we do next? What do we do? We'll plug it in to the DE. Yeah, plug into DE and see what happens, right? So I'm going to write that down. So plug into DE. Let's see. Plug into DE. So we have the second derivative, so I'll write that again. So 2a e to the 5x plus 10 parentheses 2ax plus b e to the 5x plus 25 ax squared plus bx plus c e to the 5x. Writing really fast. I can't write any faster, so let me pause. If I'm writing fast, that means you're still catching up. So they say you can write faster on a board than on paper. I don't know if that's true. I think so.
I agree.
You think so? Because it's so fast. Watch.
Slides often easier. Yeah.
There's another teacher here. He teaches physics, and he was in my office once, and he wrote down the integral sign, and I freaked out because he wrote down so fast. He was like, whoa, it's like super fast, just so fast. Like he writes so fast, like it's just like so fast.
Like for the limit, you usually like
I had a teacher who used to do that. He would do limit. Yeah, he would do that. It was really hard. Plus 5y. So, oh, it's just 5 times this.
But it doesn't repeat, so nothing simplifies.
Okay.
Yeah, nothing fancy, just
Really? Okay.
because we don't have any negatives.
Well, I guess you can add it to 25.
Yeah, I guess it just bigger.
Oh yeah, we can. We totally should. And now what's that equal to?
Your negative 180 x squared equals 5x.
Okay. Good stuff. I guess maybe we should clean that up a little bit, right? You want to combine these? These?
Makes it 30.
Yeah.
Yeah, let's just go ahead and do that. If you look at my notes, I probably didn't do that because I'm super lazy. Like I was thinking, I don't want to do it. I was just thinking that. But I thought, no, I should do it. It's a classroom. It'll make it easier. That 10, I'll leave it there. You can probably distribute it, but I'll leave it. You could probably multiply it all out and stuff might clean up, but I don't see any nice negative signs. So 30.
There aren't those.
There are no, yeah, there's none, right? That's kind of unfortunate. Last time we had all those negative signs, now we're like, we wish we had them. We wish. All right. So I guess now we're going to equate coefficients. Basically, everything is an e to the 5x term. So in theory, you could divide everything by e to the 5x, but that's not worth it. It's an extra step. Let's maybe start with the highest order, the highest term, highest degree terms, ignoring the e to the 5x. That would be the x squared e to the 5x terms, right? X squared. So I'll write that down. So let's look at the x squared e to the 5x terms. So let's see, where do we have those? There's none here. There's none here. I think there's some here, right? 30ax squared e to the 5x. 30ax squared e to the 5x. So 30a. 30a. That's the only one. What should that be equal to? Negative 180. That feels really good, doesn't it? Like it worked out really nice. So again, I wasn't sure. I wrote this down. I was thinking, when I wrote this down, I'm like, I was thinking like, what is going on? Like, what are we going to do? But then I was like, no, we should be able to do it. It's, So look, x squared e to the 5x. That's that. So we just looked for that one. That was here, 30a x squared e to the 5x. So that means a is equal to negative 6?
Yes.
That feels really good. It's like, yeah. It's way better than 28 over 25. See how we did that?
Yeah, it's just that the distribution is just the fun of that.
Yeah, 30a x squared e to the 5x. It's ridiculous, right? Yeah, this is like, it's a whole nother level of math. I guess let's go down a step to x e to the 5x.
So how are we looking for these? It's not based off on something, right?
No, go ahead.
No, sorry.
I was just thinking like they all have an e to the 5x, right? So I was looking at the powers of x. The highest power of x was x squared. So let me just start with this one because I saw the negative 180. I thought it's going to give us something.
It's just everything else is going to be equal to 0, right?
Yeah. Yeah, everything else is going to be 0.
So you just go down the powers of x until you don't have.
Yep. Yeah, just go down the powers of x until you just get to the e and the constant. And there's no constant, so it'll just be.
So aren't b and c going to equal to 0?
Maybe not. I don't know. Let's see. I don't know. So that one's no good, right? But here we get 20a. 20ax. Let me see the 20a. So 20. A. Almost lost a point. Oh, what about here? 30b. 30b, right? 30b. 30b. So plus 30b. And that's it. What's that equal to now? 0. So yeah, they're all equal to 0, but they're not all going to be 0 because you have a sum equal to 0. And we know something about a. It's -6. So it's 20 times -6 plus 30b. That's equal to 0. So -120. Kind of slow on these. Going slower on these examples. This is tough. Add the 120, divide by 30. I think b is 4, right? Yeah. Because you add 120, so 120 over 30 is 4. So b is 4. Bless you. Gesundheit. Is it? How do you say it? What? Gesundheit? Tot? Gesundheit. Tot. Okay, that doesn't matter. Okay. So now we look at the e to the 5x terms.
So that's your 2a, and then your c, right?
2a. Oh, 10b. 10b. There's a lot of stuff in this last one, huh? And then almost 30c.
Oh, sorry, I was looking at the wrong.
It's okay. It's late. 30c. And that's equal to 0.
It's not 1 since the coefficient in front of e to the 5x.
No. What coefficient? There's no e to the 5x here.
Because like the one.
I thought no.
A is -6, so it's 2 times -6. B is 4, so 10 times 4 plus 30c. That's equal to 0. So we have -12 plus 40. Oh, 28? 28? So tough, right? Like, sort of wear down. 30c equal to 0. So 30c equals -28. Fractions. Oh, there we go. -28 over 30. Fractions are our friends. -14 over 15. Yes, Modu.
Why is it just equal to 0, not the -180?
Because there's really a 0 times e to the 5x here. And so you set it equal to 0. That's for the x squared. That was just for the first one. Right, you want to think of it, you can think of it like this. Plus 0x e to the 5x plus 0 times e to the 5x. So when you're looking for the e to the, when you're looking for these, you just get the 30a, right? And then you get the -180. And then when you're looking for these, you get 20a and then 30b x and then equal to 0 because it's not there. See? 0? You see the 0 in front of it? No? Okay. I don't want to. Okay, let me come down here. 30c. Let me fix this so that people can see. So, do you see that I can do this? Because what's this going to be equal to? 0. So it's there, but not really. But and then same thing here. So then this one, right? This one, we just got this 30a. You see it? And that's equal to -180. And then this one, we did 20a x e to the 5x, and then 30b x, and then that's equal to 0. I'll finish the next one. And the next one, the last one was the worst one. The last one was just e to the 5x. So 2a plus 10b plus 30c. That was this. And that's also equal to 0. Does that make sense? Yeah, it's tough. It's tough. It's really tough. I feel like this one was harder. I agree with Matthew. Right? Right? What made it hard? This is the derivatives. Just.
Well, the cosines and the sines are just the minus and the increase. That's really the hard part.
Too many x's. Yeah. 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 All right. So let's write the answer down. So the answer to this one.
That's just numbers.
Where's the YP? Oh, it's way over here. I'll write it here. So the answer to part C is YP equals, I forgot, what was A? -6?
Yeah, 6 plus 4.
Plus negative.
That should be negative.
It is a neg. It is a neg. It's there. You see it? It's there.
Yeah, that's the first.
And then -14 over 15. Thank you. -14 over 15. And then it's e to the 5x? Like that? So that's your YP.
And then
The answer, yeah, good, Rafael, you got this. The answer is the YC. So part D, yeah, we'll say find, write the general solution. So write the general solution. So solution, it's y equals, and I'll write it out, YC plus YP. Let's make it count. So y equals, so YC is here. This thing here with these cosines and sines. So C1 cosine square root 5 times x, running out of room, plus C2 sine square root 5 times x. And then we have that piece over there plus parentheses -6 plus 4x, -6x squared.
Plus 4x minus 14 over 15. And parentheses 8 plus x.
Perfect. Boom. That's it. Good stuff.